I'm back with our next class. In today's class, we are going to discuss family Fabaceae. This family is well distributed throughout the world, and previously it was known as a subfamily under Leguminaceae called Papilionode family. Okay, now we consider it to be Fabaceae family. So let us learn about Fabaceae family in today's class, and first we'll start with vegetative characters. See, first, vegetative characters. The habit of the plant, they are trees, shrubs, herbs and climbers. Alright. Next, root. The root would be taproot system, and the roots would be found with nodules. If you remember, nodulated roots, isn't it? The nodule formation can be seen in the secondary or tertiary branches of certain leguminous plants, okay? And these tumor-like projections possess a bacteria called rhizobium. The rhizobium bacteria can fix nitrogen, and hence it can increase the soil fertility by enriching the soil with nitrogenous compounds, right? And nitrogen being the most critical component or the most critical element in the soil, something that is found in deficient quantity, when it gets enriched in the soil fertility enhances, also the productivity of the plant or yield of the plant would increase, okay? So here, see, the roots are branched with nodules. The nodules would possess rhizobium bacteria. This is the bacteria I was talking about. The bacteria which can fix nitrogen. Alright. And hence will increase the productivity of the plants. Stem is erect or they can be climbers as well. Fine. Next, leaves. The leaves shows alternate phyllotaxy as in the spiral phyllotaxy, right? Where in adjacent nodes, okay, one node will give rise to one leaf. That is the first thing. And in two adjacent nodes, the leaves will be in opposite direction. So that from the top view of the plant, if you see the leaves, they would seem to be arranged spirally, right? That's why spiral phyllotaxy is there. Generally, the leaves are pinnately compound. They are stipulate, means they possess stipules, and pulvinous leaf base. Pulvinous leaf base, if you remember, it should be pulvinous leaf base. Pulvinous leaf base means a leaf base which is swollen, isn't it? Leaf base swollen would be known as pulvinous leaf base, right? And it is a characteristics of Leguminaceae again, right? And reticulate venation. Reticulate venation means the veins and the veinlets will together come up and will together, associate to form reticulate or network-like formation. That's reticulate venation. All of these terminologies have been discussed, right? So in that case, it would be much easier for you to understand. So that being the vegetative characteristics, next let us move on to the more important characteristics, that is floral characteristics. Okay, so floral characteristics of Fabaceae starts as such. The inflorescence is racemose. Okay, then the flower would be bisexual. That means both androecium and gynoecium would be present. Zygomorphic, that means the flower can be divided into two equal halves from only one plane. It's an isobilateral flower that we are talking about. Hypogynous means ovary superior, isn't it? Ovary will be at the topmost position and rest of the floral parts would remain below it. Bracteate, the flower would possess a bract, okay? A bract is a lateral appendage, a leaf-like appendage which would be present at the base of the flower, and the flowers would be pentamerous. That means the floral parts would be in the number of 5 or multiples of 5. That's what is a pentamerous flower, right? Fine. Next, calyx. Calyx, sepals 5. There are 5 sepals. Gamosepalous. That means all the sepals would be fused together. Valvate or imbricate estivation. Right? Next, corolla. Corolla also, if it is a pentamerous flower, of course, petals will also be 5. Polypetalous bud. It was Gamosepalus. The sepals were fused, but the petals, they are not fused. They are all free, polypetalous. Papilionaceae or papilionaceous corolla. We have discussed papilionaceous corolla. If you remember, this papilionaceous corolla will have 5 petals, and the petals will be again of 3 types. The outermost would be the largest, that is the standard or vexillum. Then in between remains 2 wings, isn't it, or ala. And finally, the innermost 2 smallest petals will be fused together also, and they are known as keel or carina, right? You remember? So, papilionaceous corolla and vexillary estivation. Of course, you know that papilionaceous corolla would be possessing vexillary estivation. In vexillary estivation, characteristic itself is papilionaceous corolla, right? Now, androecium. Total 10 stamens. Okay, 10 stamens are present, and diadelphous condition. Now, if you remember diadelphous, adelphous itself means filaments of the stamen are fused and anthers are free, and di means 2. So, in that case, in the flower, 2 separate units will be formed of fusion of filaments. Okay, fused filaments of stamen will create 2 units. Now, interestingly, in such flowers, say out of the 10 stamen, 9 of the stamen will remain fused to form 1 unit, and there will be 1 extra single stamen that will be behaving as another unit. So, diadelphous condition means 2 units of fused filaments of stamens. 1 unit will have 9 stamens fused together. Another unit will have a single stamen. It's a very interesting arrangement. Do remember that. Okay. Next, gynoecium. Gynoecium is ovary superior, as I've already told you previously. The flower is hypogynous after all. Monocarpillary, unilocular, and marginal placentation. You already know marginal placentation as in P, isn't it? So, marginal placentation means ovary will be unilocular and there will be many ovules present, right? Fruit is legume, that is again in P, the fruit was legume, right? And seeds would be 1 to many and non-endospermic. Alright, so knowing the floral characteristics, if you are very or pretty clear about the floral characteristics, using that, let us see how to write the floral formula and then make the floral diagram. Okay, so look at this. Here, I've written the floral formula first. So as you know, the sequence that we need to follow, first we have to mention whether the flower has bract or not. Then we have to mention the symmetry of the flower. Then we have to go for the sexuality of the flower, that is going to be unisexual or bisexual. And then as usual, calyx, corolla, androecium and gynoecium, right? Keeping in mind this sequence, let us start. So you know that in Fabaceae, the flower is bracteate, isn't it? It's bracteate. So bracteate is symbolized by Br. So we started with Br. Then the flower is zygomorphic. The symmetry is zygomorphic. So the symbol to zygomorphic is this, right? And then bisexual, right? After that, let's start with calyx. Now calyx, you know that there are 5 sepals, and these 5 sepals will be gamosepalous. They are going to be joined together, right? And they are all alike. So what we will do is we'll write K subscript 5 and the 5 will be under bracket. Bracket shows fusion, alright. Next, corolla. Corolla also you know is petals 5, but then these petals will be of 3 types. 1 standard, 2 wings, 2 keel, isn't it? And the keel will be fused. So how you will write that in the formula? C subscript 1, that is for standard, plus wing, that is 2, plus 2 under bracket, that means keel, the smallest one were fused, right? So in that case, the 2 will be under bracket. Fine. Standard, wings, keel or carina. The carina would remain fused, that's why it will be under bracket. Fine. Next, androecium. 10 stamen. And diadelphous, where I told you that 9 of them will remain fused to form one unit, and there will be another stamen which will be single and behave as another unit, right? So in that case, A, 9 under bracket, 9 of them show fusion plus 1, total 10. Understood? So this is how you write diadelphous condition. Finally is gynoecium. Gynoecium, you know, is superior ovary and unilocular. So this is how you write superior ovary, and because it is having only one locule, unilocular, so one doesn't have to be again under a bracket. So superior ovary, so superior ovary and unilocular, 1. Fine. So I hope the floral formula is clear to you. Now next is floral diagram. So now let us discuss the floral diagram. So if you look at the floral diagram carefully, you can see that we have started the diagram with a dot. That is the position of the mother axis, right? Now let us start the floral diagram. Of course, you know we'll start with the outermost hole, that is the calyx, right? Calyx will show 5 sepals and fuse together. So these are the 5 sepals. See? 1, 2, 3, 4 and 5. 5 sepals which are fused. This is how we show fusion. These are fused to one another, right? Next, inside that remains the corolla. Now corolla, you know, is vexillary estivation or papillonaceous corolla, right? So in that case, this being the vexillum or standard, these two are the wings, and these two, the smallest one which are also fused, are the keel or carina. Okay, so this is how you make the corolla inside the calyx. Now internal to that would remain the androecium. So androecium, you know, 9 of them are fused. So these are 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of the stamens are fused and 1 is a single unit. Okay, so in that case diadelphous condition is shown here. And at last we have a unilocular and we have a monocarpillary superior ovary. So here a single ovary with a single ovule, that usually shows in case of marginal placentation. Okay, and finally last thing is whether the flower is bracteate or ebracteate. So as you know it's bracteate, so this is how you refer the bract. Okay, so this is the floral diagram of Fabaceae family. I hope the floral formula and diagram are clear to you. So now finally for the exam, as examples are important, let us see a few important members of this family which are of commercial importance. First, pulses. Pulses are many. Okay, there are many types of pulses found in the Fabaceae family like gram, arhar, sen, mung and soybean. Likewise, fodder, that is animal feed. There are 2 types of fodder as well, like trifolium and sesbania. Edible oil. Edible oil are soybean and groundnut. Dyes, okay, from where you extract color, that is indigo fera. Then coming to fibers, the fibers are extracted from sun hemp. Then ornamental plants. Ornamental plants are lupine and sweet pea. And medicines. Medicines is muletti. Okay, so these are important members of Fabaceae family. Do remember these examples are very, very important because finally from families as well, example oriented questions will be asked. Okay, so in that case that's all regarding Fabaceae family. In the next class we'll start with Solanaceae family. Thank you.